Let's understand what Newton's third law tells us. Now, we have already seen this statement before that for every action, there is an equal and opposite reaction. It's a very familiar statement, but what it does not do a good job in helping us understand what is action and reaction. So we're going to say that this is not a very clear statement to help us understand the forces, and we do not know what is the action and what is the reaction. But we also know that this is the usual statement that everyone knows. Let's come up with a clearer statement. Let's say that if object A causes a force on object B, then object B is going to cause a force on object A. And the forces from A on B is going to be equal in magnitude, but it's going to be in the opposite direction. Now that helps us understand it in more in detail of how let's mathematically write it in a statement. We can write it in this mathematical relationship, which tells us the force of A on B is equal to the force of B on A. What this equation also helps us see is that the sizes of the forces are the same, and it's also telling us that they are in the opposite direction. And the negative sign helps us understand the opposite direction of the forces. So if there is always a force equal in magnitude and opposite in direction, then how can anything move? That's a big question we have from Newton's third law. Now keep in mind that Newton's third law relates the forces on different objects. So we can understand how the different two objects are going to interact with each other. And when we break it down to Newton's first law and second law, it helps us apply it to individual and isolated objects. So basically, third law is going to help you relate the forces on different objects, whereas first and second law is only on isolated or separate objects. Let's take an example of polar bear and a penguin. So polar bear is going to be of a bigger mass and penguin has a smaller mass. And let's say the polar bear is going to apply some force on the penguin. And let's say the force that the polar bear is going to push the penguin to the right, and it has applied a force of 50 newtons. So let's write it down. Polar bear pushing the penguin to the right with a 50 newton force, and the masses are also 250 for the polar bear and 10 for the penguin. Now what is the force on the polar bear? Now, if we understand it by Newton's third law, we know that the force of the polar bear on the penguin is given to us, but it should be the same force on the penguin, from the penguin on the polar bear, but in the opposite direction. So if we know the forces now, we can actually quantify and see what is the acceleration of the penguin and what is the acceleration of the polar bear. So that's where we'll use Newton's second law again and quantify the acceleration. And when we do the calculations, we're going to use the forces that we determined from Newton's third law. So write down Newton's second law. Again, we know the force of the polar bear on the penguin is 50 newtons. So we're going to figure out for the penguin, the net force is 50 newtons to the right, so I'm going to keep it as a positive number. And the mass is 10, and the acceleration is going to be 5 meters per second square. It's going to be in the same direction as the force towards the right. And when we figure out the acceleration for the polar bear, we again use Newton's second law. The force this time is to the left, so I'm going to use negative 50. Plug in the mass for the polar bear, and the acceleration comes out to be a small number, which is 0.2 meters per second square, and in the opposite direction. So what intuitively understand from Newton's third law is that although the forces are going to be the same magnitude and opposite directions, but the cause that or the effect that this force has on the different masses is going to be different. As you can see, the acceleration on the penguin having the smaller mass is going to be higher as compared to the polar bear with a bigger mass is going to have a smaller acceleration. So let's take a look at another example. This time we have a truck, and let's say a fly is flying and it hits the windshield of the truck. So the truck hits the fly and the truck is applying a force to the fly. And according to Newton's third law, if we understand how much force is on the fly and how much force is of the truck on the fly is going to be the same as the force of the fly on the truck, but it's going to be in the opposite direction. Now it seems counterintuitive that the fly is going to feel a force and it's going to get squished, but the truck is going to act like it didn't feel a force, but it did. And we know from Newton's third law that the force is going to be the same amount, but it's going to be in the opposite direction. Now, if we want to understand the difference, what is happening, we can see that the truck mass is going to be larger than the mass of the fly. And they're very different masses. And Newton's second law says that it's the product of the mass and acceleration to get the net forces. But if we break it down or understand the acceleration, the truck acceleration is going to be very small because of the bigger mass, and the fly acceleration is going to be huge because of the smaller mass. And because of the bigger acceleration, the result is that the fly gets squished. Now let's say it experiences let's put a number for the forces and try to understand. So if we say that there's some force from the truck, 5 newtons on the fly, it's a lot to squish the fly. But the 5 newton on the truck from the fly is not a lot, and there is an effect of this force and it changes the motion a little bit, as you can see from the acceleration.